Okay, we have here today a pretty interesting integral. This one's from the UNSW Integration Bee 2020 semifinal round 2 problem 3. We have the integral from 0 to 1 of sine x sinh x minus 1 dx. Okay, at first I really didn't know where to start with this just because it's so unusual to have sine and sinh in the same integral and it's not clear how those work together, probably not very well. I tried breaking this up using the definition of sinh and breaking it into two integrals. It seemed like it might work, but it was just making it more complicated, so that didn't really seem to help. The graph of this was kind of interesting because you'll notice at 0, this whole thing becomes 0 because sine at 0 is 0. But then it's also 0 at 1 because the sinh of 1 minus 1 is sinh of 0, and that's 0. So the graph's pretty nice, but I can't tell just by looking at it what the area is. It wasn't like I could just see that it's 0 or pi or whatever. But what I came to is we actually just have two functions here, and they're both easy to differentiate or integrate. So why don't we just try integration by parts on this and see where it goes. So for integration by parts, what I want to do is the DI method, or tabular integration, of course. So we'll set up our two columns. One to differentiate, one to integrate. In this case, I think it really doesn't matter which we choose because they're both easy to differentiate or integrate. So I'm going to choose to differentiate sine x, and I'll integrate sinh of x minus 1. Then we'll come over here, we'll take a derivative of sine, and that's just going to be cosine x. And I'll do it one more time, changing this to plus. This is going to be derivative of cosine x is going to be minus sine x. Now coming over here to integrate sinh of x minus 1. Now the integral of sinh is going to be just cosh. And now because the input's just x minus 1, you don't even need like a u substitution. So this is just going to be cosh of x minus 1. And then doing this again, this is going to be just sinh of x minus 1. So then we'll have part of our solution right here, and this last row is going to be an integral. So let's just copy all this stuff down. So for the first part, we're going to have just sine x cosh x minus 1. And then for this next one, we're going to minus sign, so we'll have minus cosine x sinh of x minus 1. But now for this row as an integral, notice that we've got sine x sinh x minus 1. This is exactly what we have in our integral. So if I just take the original integral and I label it I, then all this, take out the minus sign, just everything over here, all this is going to be I. So instead of writing this integral in here, I'm just going to write this as minus I. And of course this whole thing will be just, we'll set this equal to I. So what I can do is just add an I on both sides in order to cancel this one off. And then over here, this is going to become 2I. But then what I can do to isolate this, I'll just divide by 2 here. And then I'll multiply this whole thing by 1/2, or I could divide the whole thing by 1/2. So I'll write it like this, but I'm just going to need to evaluate this thing from 0 to 1. Okay, so first what we'll do is we'll evaluate the upper bound at 1. So this is going to give me, I'll just bring the half out front, and then we're going to have sine of 1. That's just going to be some numeric value, so we'll leave that. Then we're going to have here cosh, 1 minus 1, so it's going to be cosh of 0, minus cosine of 0. And then here, this is going to become sinh of 0. Then next I'll evaluate this at 0 down here. So this is going to become, so this first piece is going to become just sine of 0. Then we're going to have cosh of negative 1 here. Then minus here we're going to have cosine of 0. And then we're going to have sinh of minus 1. But now sine at 0 is just 0. So this term's going to go away. Sorry, this here is a cosine of 1. I just updated that value. Now here we have cosine of 0, that's just 1, so we'll cancel that piece off. So let's just look at cosh of 0 and sinh of 0. So for cosh of 0, this is going to become e to the 0 plus e to the 0, or e to minus 0, which is just e to the 0 over 2. But this is going to be 1, this is going to be 1, so this evaluates to 1. So I'm going to cross this off as this piece here is just a 1. And then for sinh of 0, this is going to simplify nicely, so this is going to become e to the 0 minus e to the minus 0 over 2, but this is just 1 minus 1, so this thing becomes 0. So if this here is 0, then this term goes away. So let me just clean it up and see what we have left. Okay, so simplifying everything here, we'll have the 1/2 out front, then we still have sine of 1 here, which is just some numeric value. This goes away, this goes away. Then here for sinh, I just need to remember distributing this minus sign. Minus times minus is plus, so we end up with plus sinh minus 1. But sinh is an odd function, so I can actually take this minus and put it there. So what I can do for my final solution for this is just write it as sine of 1 minus sinh of 1 all over 2, and that's it. So there you have it, pretty unusual problem from UNSW 2020. Thanks everyone for watching. Have a good day.